Do you want to know how to make the perfect Unibeam for any Iron Man suit, where I'm going to take you through all of the files, all of the paint, all the electronics, and how we're wiring everything together, and all of the code for absolutely free? Well, let me show you. Hi everybody, welcome back to the channel. My name's Luke, and in this video, I'm going to be showing you how I made this, my Unibeam for my new Iron Man suit, coming up very shortly. Now this thing is fully resin printed. All of the code, all of the electronics I'm going to be talking about in this video. I'm going to show you which files you're going to need, and we're going to be making this the absolute perfect Unibeam. You are not going to get anything better. And at the end, we're going to be putting this into a completed Iron Man chest plate. So stay tuned to the end. So the first thing that we need to do is go through and talk about what files we need to do and how we're going to sort of be orientating some of these prints to actually achieve printing these, because there are some very difficult pieces to print. So we've got to make sure our settings are perfect for our resin printing. All right, so now it is time to talk about the files. So for these files, I'm gonna be using NeoRobotnicks Arc Reactor or Unibody Arc Reactor Unibeam kit. NeoRobotnicks has genuinely the best Arc Reactors, Unibeams, anything you can get. And he gives all of his files away for free. So there's no reason not to use them. So this is the place that we're gonna be downloading them, is on Printables. And as you can see, you've got the VR, you've got Unibeam, you've got hundreds of different ones, but the ones we're going to be using is this one, which is Unibeam. And you can just go down in the description and you can just download the files, download them all, import them all into MeshMix and sort of divvy them up into their separate ones, just because this kit has so many parts in it. But once you've done that, we're going to download it and separate it to something like this. Now what I'm first going to say is that this piece and this piece are not going to be in the files that you download. I'm slowly sending these over to NeoRobotnik, and he's going to be adding these to the kit, so quite possibly when you start building this, they are available to be downloaded. But at this current time of filming this, which is the 16th of November, this isn't a part of the file set, but I'm making sure it is, just because it's going to make your Arc Reactor look 1,000 times better. So we've got the main base piece, and this is what's going to help us take in and out our electronics when we've actually glued things together. We're going to keep this one separate and add little tabs so it sort of friction fits itself in and holds together. We've then got the main body that goes all the way around. That's going to obviously sit and give us our electronics room and sort of make it physically an item. Then we've got this piece, which is our detail ring. This is what goes around this piece, which is our clear resin piece. So this is the only piece that will need to be printed in clear resin. The rest of it you can print in whatever color you want. If you want to go clear, go for it. And basically this piece sits right over the top, so it looks something like that. And that way we can paint this piece Alumuluster or a chrome, and then friction it onto our clear piece, and it adds 1,000 times of detail, and we don't have to do any hand painting or anything. And then this little top jewel piece goes into the top, so that it looks a little bit like that. So I'll leave a link down in the description where you can download these files and just download them, split them up into bits and pieces. You are going to need to take some measurements and scale them. For me, in my suit, the Mark 47, it's going to be, I think it was 60 mil in diameter. Whereas the Arc Reactor for Melbourne Iron Man is about like 80 mil. So it's obviously different for each and every suit. So scale it to what you need it to be. But don't make it like an oval or anything. Make sure it is symmetrical the whole way around. You're gonna have a much easier time making this work. And obviously, like I said, you might be able to download these two rings very soon, but at this current date, not yet. But we are going to need to, before printing anything, edit one file and actually, well, make our own file. We're going to jump into Tinkercad, just a free 3D modeling software, and make something exactly like this. So basically what this is just a small circle piece. Now for our LEDs, they're going to be super bright, and our resin printed Arc Reactor clear cover piece is going to be so clear that you're going to see every pixel. So we need to make like a diffuser. So all I've done is take the measurements of my Arc Reactor piece, which is 53.5 by 53.5. The nice even circle that can friction fit straight into our Arc Reactor shell. So we're going to print this and model this. Just import a cylinder into Tinkercad, move it out to what measurements you need, and then make it about 5 mil thick. That's what I find works best. And as you can see, I can do that very simply. So there you go. Import into Tinkerpad a nice little cylinder, extrude it to what dimensions you need, jump up to this corner and click export. And for this piece, we're going to be printing this in clear filament on an FDM printer, not resin printed. If you resin print it, it's going to look clear and it's going to defeat the whole purpose of a diffuser. So we're going to print this out of just a clear filament. For me, I didn't have any clear filament. I just had glow in the dark, which is basically clear filament. And we're going to be printing this at 50% infill. That way there is more light that has to bounce around and it's not as clear, diffusing the light. So just print that. I printed it on my Bamboo. You can print it on whatever printer works best for you, but we need to make that piece so we can add it in just at the very end so that every light is diffused perfectly. The last piece we also need to do is I'm just going to show you how I oriented all my prints, because I tell you, this outer detail ring is going to break. I did it really well that I didn't actually break one of them, but it's going to break, trust me. You just need to be incredibly careful. So for these outer rings and this detail body and this front plate top detail piece, just print them all on an angle and make sure your supports are set to light. You do not want these heavy, you don't want them overdone, and just try and make them as brittle as possible. As for this clear piece, do obviously print this in a separate print. I'm just showing you the orientation for this one. And for this detail piece, try and make it at an angle where supports aren't really touching these detail pieces. You're going to want to take these off really carefully. Take a nice pair of snips and just seriously break it away, one support at a time. I think it took me about 20 minutes to remove all the supports on this piece. Obviously that's an incredibly long time, but the results are totally worth it. And when you take that time, things are going to look amazing. So obviously take your time when you do this, don't rush it, or you'll be printing about 1,000 of them. And when we paint this, we want to print an extra one of these. I know I said we don't print one solid, but we are going to print one solid at about a couple mil smaller than the actual diameter of this. So say our arc reactor is going to be 50 mil in diameter, print this thing in a diameter of 50 mil, but print this thing at maybe 45 mil. So what this is going to do is we're going to add our paddle pop stick onto that and our case, so we can put this arc reactor detail piece over the top. That way there's no glue, there's no nothing going onto this piece, giving us the extra availability to not shatter and destroy. So that's pretty much all when it comes to printing these and our files and doing some tiny modifications. The last thing I'm going to say, to make this clear piece extra clear, we're just going to go into our slicer setting. So I'm just using cheater box for this, but if you just go into the resin tab and you see this is layer height. My default is 0.050. But you're going to want to jot this one down to 0.010. This is going to basically make the layers even smaller, so it is going to bump your time up drastically. Things are going to take a lot longer. Something that might take half an hour is maybe going to take now 4. But what this is going to do is make your job when you do the resin printer, like buffing and polishing and clear coating, making this thing crystal clear, 1,000 times easier, and the detail is so worth it. So you can just leave this completely off when you do the main body, the base, and the details. But when you do that one clear arc reactor cover, just punch that setting down to the 0.010. You're going to get better results. So with that all out of the way, let's start paddle popping all of these so that we can get our nice gloss black on it, our Alumuluster and clear coat, so then we can do our electronics and then just fit everything together with little dabs of glue. So let's go. The other thing I want to talk about before we actually paint is the code. Now for this, I'm going to be using a Wemos D1 Mini. Now if you've ever used a Wemos D1 Mini, they're basically a mini Wi-Fi board. I'm absolutely in love with these things. And that means later down the line, I can start connecting this, say, to my helmet or to a repulsor signal or something in my wrist that then could supercharge the arc reactor and, well, make it look 1,000 times cooler. So essentially, this is the code. I've written this one up roughly myself with a little bit of help of ChatGPT, but I'm going to be supplying all of the code down in the description for you guys to download for free and upload to whatever. Now this will also upload to an Arduino Nano if you would prefer to use that. But essentially up the top, we've just got the LED pin. That's what pin is wired up into our Wemos, which is going to be D5 in our case. Then this is the chipset of our LEDs. So most of the time they're WS2812s, but sometimes they could be a WS2812B. Just make sure which model you're using, just so things work a little bit smoother. Then the other thing is just the number of LEDs we have. So in my case, I've got 21. And then basically the rest of this is doing a startup sequence. As you can see in this video, when I plug this thing in and boots up, it boots up into a nice glowing fireworked orange. and then after 3 seconds it turns off and then sets into its default blue. So basically that's just saying the max brightnesses and our frames, basically the duration of how long we want everything, and well, a bunch of other stuff that I don't really understand. I just use it. So that's it for the code. I'm going to leave a link, like I said, down in the description where you can download this one for free and just upload it using USB-C. If you are interested and have some troubles uploading into your Wemos, I'll leave a link down in the description of my Mark 47 tutorial of Wi-Fiing Iron Man suits. It just has a little bit of details in there just so you can figure it out. But Wemos is a pretty easy to upload code to. The other thing I want to talk about is our LEDs. I bought this in a kit on Amazon. I'm going to leave a link for that as well down in the description. See if you can buy it because this thing truly is awesome. So it comes as a massive big sheet like this, and you sort of just cut the tabs out of which LED rings you need. In my case, I took the 3 smaller ones, and this is what we're going to be wiring up later in the video, so don't worry about the wiring as of yet. But it's just basically individual LED pixels on a ring mounted together, so I don't have to worry about mounting anything anywhere. All the LEDs are stuck together as one, which is amazing. And then we're just going to need some JST connectors and a USB power lead with a positive and negative on it. If it's got 4 pins, don't stress, they're just data, we're just gonna leave them. We'll talk about that later though, so don't stress. But that is your files, that's the board we're gonna be using, and the LEDs, I'll leave a link down in the description. If not, just buy some LED rings and sort of stack them onto each other, glue them up together so they're in one place, or if you wanted to, 3D model like a little bit of a thing in Tinkercad and make something work. But that's what we're using for our electronics, which we'll talk about later. Now that the code's out of the way, let's actually go and talk about the paint. All right, so let's go through the paint. Now, this paint is incredibly easy. But before we get into all the paint, all of your prep work is going to be relatively important to getting this right. Resin printing, make sure you wash and cure all of your parts perfectly and give them a little bit of a wet sand before priming. When you prime it, just do nice, really even coats and then wet sand that one back. Now, obviously this outer ring detail piece, I didn't wet sand. I ain't breaking that or ruining it. But the bottom, the side cage, and the top little detail piece that lives in here, give them a wet sand and a prime and prep them really nicely. Don't really need to do too much sanding. Don't worry about your outer detail because we won't want to break that. When it comes to making the clear piece, the prep work, obviously in printing beforehand is really, really important. So like we said with the settings, we need to make the exposure really low. Yes, it's going to take forever, but we're going to get crystal clear results. So it doesn't matter. But you basically just want to give it a wet sand, clear coat, buff and polish. It'll be perfect. So watch that video if you're interested on how to sand that and prep it perfectly. But onto the paint. So we're going to put little paddle pop sticks on everything and hot glue them into really nice positions. That way we can paint them and bend around them and do all our detail work. We don't need to worry about trying to hold it awkwardly on our fingers and paint it, get it all over our fingers, and then ruin something. So glue them onto paddle pop stick. That's a pro tip for you. But we're going to coat the whole thing in an Elasa 2K gloss black. So this is just a 2K gloss black. You see me use this on everything. We're just going to spray a really nice even coat around everything. And that's going to lay our foundation for, well, our Alumuluster. As for the Alumuluster, it's going to be, well, a little bit different. We're actually going to be airbrushing it this time. Just because a lot of these pieces are really, really small and I was doing other bits that needed to be airbrushed, we don't want to overdo it with the HVLP gun, so we might as well use an airbrush. Now I know that I always talk about the iWater Eclipse, but this is the SMS Dragon Air. This is the one I use all my lacquer stuff in, so my clear coats, my candies, and my Alumuluster. Whereas my Eclipse I will keep clean and perfect for all my acrylic paints for my weathering or detail pieces. But we're just going to load up the gun and just spray it at 20 psi. Really nice even coats, don't go too heavy. It's the exact same as with an HVLP gun, don't overdo it. And we're just going to build those layers up and up and up until it's a really clear, glossy, high perfectness of Alumuluster. After that's done, well, it's clear coat. Now you might be thinking, if you've seen the channel before, we're going to be using MS222K Clear, but that's where you're wrong. We're actually going to be using some SMS Super Clear. This is just a super, super high gloss clear in an airbrush form. So we're just going to load this up into the airbrush and spray really, really nice coats. We're going to be doing about 2 to 3 coats, very similar to your big rattle cans or an HVLP gun sort of clear coats. But in this form, we're going to be putting it through an airbrush because all our pieces are so small. And the last thing we want to be doing is flooding them with clear coat. So we're going to be doing the bottom, the side, the top, and all around our ring. And then that's it. That's all our paint complete. That's it. You only need 3 different paints to do the entire paint job. So next thing we need to talk about is doing our electronics. So we're just going to be soldering everything up. I have not tested these into the Arc Reactor first, which was probably a bad idea, but foreshadow, it does fit all perfectly. But the next thing we're going to do is, well, wire this thing up. Okay, so time to wire up this thing. Now the first thing, we're using a Wemos D1 Mini for this. Following on from that, we've got our 2 JST connectors. This is just a 2-pin. These ones are going to connect it together. So basically, this is what we're going to be making in the end. And as you can see, I've just mounted it here. That way I get a little bit more room if I needed to pull something in or out or just disconnect it entirely. I'm going to add one on this pin just because. But at this stage for this wiring diagram, we're just going to end up using a straight cable. On from that, that's that straight cable that's just going to connect our pins together. And then we've got these. We've got our signal sort of wires. So we've got our DIs and the DOs, times 2 of them. We've got our 2 5 volts and our 2 grounds. And last but not least, our little Arc Reactor piece or all of our joules from our LEDs. And as you can see on the back of this, this is what we're going to be soldering to, are these contact pins. I'll make you a winder diagram. This is what it looks like. And that way you can kind of just base it off a diagram. I'm going to show you how I wire it best. Now for this wire, it isn't actually really wire. It's more of like a steel sort of wire. It's not like wire like this, where it's got multiple different strands through it, but it's this sort. I got these out of the Arduino IDE kit. This is the kit you buy when you start your Arduino sort of journey, and these are the cables that end up coming with it. And I've just taken the time, bent them and shaped them to match these diagrams or whatever. So do with that as what you will, but these are the wires I'm using. That way I can just bend and manipulate them a lot easier. So we're just going to end up adding some solder to each of these little contact pins. Now if you look at the wiring diagram, when you notice, you're going to have a DO, a 5V, a GND and a DI. So basically the 5 volts all go together, they're your 5V. Your GND, which is your ground, are all going to go together, but it gets a little bit different when we talk about the DI and the DO. So basically this is your main centerpiece. This is where every information comes in and then all of the information goes out from on there. So we're actually going to start by soldering into the DO, which is digital out. And we're going to be soldering that into digital in. So that's our data coming into this next ring. Then we're going to be going digital out from this ring and digital in to this ring. And say if you had a couple extras, it'd be DI, DO, DO to DE, DI, DI to DO. So basically what we're doing is taking the information from this to this and taking this information, giving it to this, taking this information, giving it to the next one. So don't connect all your DIs together and don't connect all the DOs together because, well, nothing's gonna work. So once that's up together, we're gonna take our first wire, which I have bent and connected, and take it from DI to DO. Cool, so that is our DI to DO and our DI to DO connected. They are a little bit fiddly, some of these, so I do recommend adding a dab of solder to the tops of either end, just that way it solders a little bit better. I did pause the video for about 20 minutes trying to get this thing to work, so take that as you will. The next thing we're going to do is connect our positives, so that's our 5 volt, and we're just going to go over the top of this and connect into there, and this one just to there. Reds are wired. Next step is our ground, so that's just going to be from the GND to the GND, and our GND to the, if I can pick this up, to the other bit. So let's go. Perfect. So now that those are in, time to start wiring up some of our cables. So we're just going to neatly swirl around the cables so that they're a little bit tighter and that they fit through the hole that we're going to need to be putting this through the Wemos. So we're just going to put a dab of solder on the end of these, but essentially this one is going to be going into our DI on our middle pixel. And the reason it's going to be the DI is because it's our input. There's nothing going out of it. So we are going to have to double up on this wire here, but that's all right. We've got enough room. It'll be totally fine. So we're just going to take this. I can actually do this on camera so you can see because it's not hard. Cool. So once that one's in, this end will be perfectly fine. I may have to put a tiny bit more solder on it actually, But the next thing we're going to essentially be doing is wiring up our JSTs onto this arc reactor. Now, yes, I could go with a 3-pin, but at the moment, I just want to go with the 2. I don't really know why, but that's going to be a later problem. If you want to switch these out for a 3-pin JST and go positive, negative, then your signal, and go 1, 2, 3 into this end, and fully be able to remove this, now that I'm thinking about this, it's probably a better idea, but for the purpose of this, and just copying what I've built here, we're just going to stick with what this is. Now, it doesn't matter which end, but I prefer to put the bulkier end on this. That's just preference. These have already got a little bit of solder on them, but we're just going to actually redo them. So we're just going to cut the ends off, strip the ends off, and tighten these ones up. And these will also get a dab of solder. So the negative goes to the negative, and our positive, well, goes to the positive. Cool. And we've also just got to cut this little excess wire off because it's touching the ground, and that's a big no-no. Awesome. So now that we've got it somewhat pretty good, I'll leave a link down in the description or an image on the screen of the wiring diagram so that you don't stuff it up, because it might go boom or just not work. So that's our arc reactor all soldered up. The next step is wiring up our Wemos. So we're going to take our positive end and shove it through the 5-volt. Now you are going to need one of these, preferably. They're a little helper scissor arm, God break it, that essentially will allow us to hold our wires while we, wire this up. Because we've got to hold our 5-volt or the ground or the positive pin into this while we try and solder it. So if we get it at the right angle, which is there, we can just cheat and go. Perfect. And that one's all wired in. The next one is our ground, so that goes to our G. Cool, and that is all wired up. So that's going to connect into this connector. The last bit is connecting this wire into our Wemos, but this is going to go into pin D5. Now you can set this to majority of these pins. Do double check your pin outs though, because some bits and pieces on your Wemos or on your Arduinos will have certain pins for certain things that certain things won't work for. So always double check what you're pinning into just to be safe. But for this, D5 works perfectly. We're going to add a tad of solder, and that's it. Last bit we're going to do is cut off that excess wire that we don't need, and that is wired. Last step to do is, well, if I can get it in, connect it. Perfect. Now you will also notice that I haven't gotten a power supply in here. Now for this is my one that I'm slowly tweaking and mucking around with, but you'll notice that it's got one of these. This is a 2-pin pogo connector. So basically, essentially what this is there's a magnetic end that goes with this. So your positive and negative feed into this, your positive and negative into that. And once you connect it, it completes the circuit. So I'm essentially going to be adding this to my arc reactor so I can take it in and out of my suit. But at the moment, I've got a little issues. I'm just tweaking things and making things work. And seeing this arc reactor is going to be for Melbourne Ironman, we are just going to leave it, let him decide if he wants to add a pogo connector, if he wanted to power straight into this, go USB, USB-C. We can code this however we want to and power it in multiple different ways. And seeing his suit's going to be a little bit different to mine, I'm just going to leave it like this. But if you wanted to, you just essentially take the, say, a USB, something a little bit like this, and just cut the ends off, and then solder the positive and negatives together straight into the Wemos. No need to worry about running it into the arc reactor or the light fixture. And then you can plug this straight into a power bank in your chest or something. But you can also see that these are the arc reactor base covers, and seeing that we've made little holes for them, it will eventually be pogo connectors, seeing that they fit, and I designed them to fit. But at the moment, we're just going to be leaving it. But I definitely recommend having a look at some of these pogo connectors. They are very weak, my ones, so maybe try and find some really strong ones. I'll leave a link down in the description. I went and grabbed them off AliExpress mine, but as you can see, they're a little bit weak, so I need to do a little bit more work. But if you're interested in that, well, stay tuned, because we're going to be doing a suit tutorial, making a whole brand new Iron Man suit, where we'll be covering off finishing the power on this one. But That's essentially all the wiring that you need to know on how to do the arc reactors. The last thing you need to do is wire this thing completely into the unit and, well, we'll have a complete arc reactor. And that is the Unibeam complete. I am really happy with how this one turned out. Compared to my original first Unibeam that I ever made, it was awful. This is next level. I'm so happy that with all the little intricate details, our little diffuser piece that we've printed out of our clear filament has diffused all of our LEDs absolutely perfectly. In person, you can maybe see it just a tiny bit, but I think if we upped our brightness on this setting, that we can get this thing crazy bright. And when the brighter it goes, we're not gonna see those pixels at all. But on camera, you can't even tell. So thank you so much guys for watching this video. I really hope that you enjoyed, and don't forget to use that link down in the description where you can go and get all of the code for free. Tag me over on my Instagram, show me what sort of code you end up tweaking and changing, because I might steal it off you and use it in my suit. But that is how you make the basic Unibeam for any Iron Man suit. So other than that, I will see you all next week for a Black Panther video, I think. But other than that, let's head to the final result.